This is the exam review video for Honors Geometry, Unit 5. Don't forget that you get this formula sheet on your exam. You're going to want to use it. And for Unit 5, these are all the formulas you're given, so you don't need to worry about memorizing anything here. You just need to know how to apply it. So for items 55 through 63, find the value of x in each figure below. Well, what we see is that we have an inscribed angle here and an inscribed angle here, and then we have a central angle here. An inscribed angle means that the angle measure is half the measure of the arc. So x is going to be half of 50 degrees, which means x is going to be 25 degrees. For 56, we're given the inscribed angle degree and we want to know the arc measure. Well, x is going to be 2 times 70 degrees because, again, this inscribed angle is half the arc measure, so the arc measure is twice the size of the inscribed angle, which means we're going to have x equal to 140. For 57, we're told that C is the center, which means that this is a central angle right here, and a central angle has the same degrees as the arc measure, so x is going to equal 160. 58, we need to find x, and what we see is that we have an angle here, but it's not the center. So when we have two chords that intersect, we know, according to that formula sheet, that we're going to have half, so x is going to be half the sum of the two arcs that it intercepts. So basically what it is the angle inside is the average of these two arcs. So 60 plus 28 divided by 2. So we're going to take 1/2 of 60 plus 28, which is 88, and half of 88 is 44. So x is going to equal 44 degrees. For 59, we're going to do the same thing, but we're given the angle measure inside this time. So 85 is going to be the average of the two arcs. So that means x plus 60 divided by 2. I'm going to get rid of the 2 by multiplying both sides by 2. 85 times 2 is 170 equals x plus 60. So then I'm going to subtract 60 on both sides, and I'm going to get x equals 110. For 60, we're told that AB is a diameter. So that means that if this is the diameter, this is half a circle, which means that the arc measure is going to be 180 degrees. So we know that angle x is going to be an inscribed angle forming this arc AB. So the measure of arc AB equals 180 degrees. So x is going to be, sorry about the handwriting, half of 180, which means x is going to be equal to 90. For 61, we have the arc outside the circle. So instead of it being the angle being the average of the two arcs, it's going to be the difference of the two arcs divided by 2. So x is going to equal 50 minus 20, the difference of the two arcs divided by 2. Well, 50 minus 20 is 30, and 30 divided by 2 is 15. So x equals 15. For 62, we have the same thing. Our arcs are going to be 290 degrees and 70 degrees. So x is going to equal 290 minus 70 divided by 2. Well, 290 minus 70 is 220 divided by 2, so x is going to equal 110 degrees. Finally, with 63, we're given the angle measure this time. So what we know is 35 is going to equal x minus 40 over 2. So the first thing I'm going to do is get rid of my fraction by multiplying both sides by 2. So that's going to give me 70 equals x minus 40. I'm going to add 40 to both sides, and I'm going to get x equals 110. For 64, we're told that quadrilateral ABCD is inscribed in the circle below. So what they're asking is measure of angle A plus the measure of angle C equals what? Well, this year we learned a theorem that says if a quadrilateral is inscribed in a circle, which this is, then opposite angles are supplementary. Since angle A and angle C are opposite angles, they're supplementary, meaning they're going to add to 180 degrees. And our reasoning will be exactly what the theorem says. If a quadrilateral is inscribed in a circle, opposite angles are supplementary. For part B, it says if AC is the diameter, what is the measure of angle D and angle B? Explain your reasoning. Well, we can look at it in multiple ways. What I can see is that this is an inscribed angle. This is the diameter. So this is a semicircle right here, meaning that the measure of arc AC equals 180 degrees. Same thing for angle B. The measure of arc ADC is going to equal 180 degrees. So an inscribed angle is half of the measure of the arc, which is 180 degrees, meaning that we get 90 degrees. So the measure of angle D equals 90 degrees, and the measure of angle B equals 90 degrees. We have to explain our answer. So one of the things that we can say is the angles are inscribed in a semicircle. So the angles are inscribed in a semicircle. Or the angles are inscribed intersecting 180 degrees of an arc. So we could say the angles are inscribed in a semicircle. The arc measure of a semicircle is 180 degrees, and an inscribed angle is half the measure of the arc. Or half the measure of the arc it forms. And then you can show your work over here to supplement this response, and that's question 64. Look at the circle O below. So we're given the circle and we're asked to determine the following. So let's start with 65, where we're asked to find the measure of arc AB. Well, we know that it's circle O, so O is the center. So arc AB is formed by a central angle, and central angles have the same measure as the angle. So the measure of arc AB is going to also equal 60 degrees. The measure of arc BC, that's right here, well, we need to find some other information in order to be able to do that. So let's come back to that. The measure of arc FDB. Well, we can find that one, so let's start with that. This angle right here is formed by this arc and this arc. So the measure of angle FDB is going to be equal to the measure of arc FAB minus the measure of arc EC divided by 2 because the angle's outside. Well, the measure of arc FAB is 140 degrees plus 60 degrees, because we found measure of arc AB, minus the measure of arc EC, which is 42 degrees, divided by 2. 140 degrees plus 60 degrees is 200. 200 degrees minus 42 degrees divided by 2 is 158 degrees divided by 2. So the measure of arc FDB is going to be equal to 79 degrees. So we know that this is going to be 79 degrees. The measure of arc EF let's see. I can see that it is formed by an inscribed angle right here. That angle measures 20 degrees, so the measure of arc FE is going to be 2 times the inscribed angle, which means it's going to equal 40 degrees. Next, we have the measure of arc AFB. That's this angle right here, and we can see that it's made arc AB, which we know the measure of. So the measure of angle AFB is going to be half, because it's an inscribed angle, half the measure of arc AB. Well, that means it's going to be half of 60 degrees, which equals 30 degrees. So we know this is going to be 30 degrees. The measure of arc FEA, that's this arc right here, measure of angle FEA, and that's created this arc right here. So again, measure of angle FEA is going to be an inscribed angle, so it's going to be half the arc measure, which is 140 degrees, meaning that it equals 70 degrees. So now let's come back to arc BC. What I like about now solving for arc BC is that we have the measure of this angle, this arc, which is 60 degrees, this arc, which is 140 degrees, this arc, which is 40 degrees, and this arc, which is 42 degrees, meaning all we have left is BC. So the measure of arc BC is going to be 360 degrees, because that's a full circle, minus the sum of all the other angles, the other arcs, which is 60 degrees, plus 140 degrees, plus 40 degrees, plus 42 degrees. So this is going to be 360 degrees minus 282 degrees when you add up 60 plus 140 plus 40 plus 42. And 360 degrees minus 282 degrees is going to be 78 degrees. and that's going to be that remaining arc, arc BC, and now we have all the arcs of our entire circle. Look at circle P below. Line M is tangent to the circle at point R. So that tells us line M is tangent to this circle at point R. We know tangent lines are perpendicular to the radius that it intersects with. So we know that we're going to have a right angle right there. We're also told that PR equals 8. PS, so this big line over here is 10. And UW, so UW is perpendicular to TZ. So we're told that we've got right angles right there. So we're being asked to complete the following, starting with find the measure of angle PRS. Well, we already know that because what we learned was that tangent lines are perpendicular to the radii at which they both intersect at. So this is going to be 90 degrees. SR, we need to find the length of that. We know that we have a right triangle. We know one leg and the hypotenuse. So we're going to use Pythagorean's theorem. SR squared plus PR squared is going to equal PS squared. Well, we don't know what SR is, but we know PR is 8, and we're going to square that, and PS is 10 squared. So SR squared plus 64 equals 100. I'm going to take away 64 on both sides. That's going to leave me with SR squared being equal to 36. So I'm going to square root both sides. And usually we, add our plus or minus square root of 36, but because this is a length, we know we're only going to be using the positive one. So SR is going to equal 6. So TU, line segment TU, that's right here, is congruent to which segment? Well, what we know is that when a chord is perpendicular to a radius, we also know that it perpendicularly bisects that chord. The radius bisects that chord, meaning TU is going to be congruent to ZU. WTU, what angle is this congruent to? Well, if we have a right angle here and this side right here, and they both share, using the reflexive property, we can prove by side angle side, side angle side, side angle side, that we have two congruent triangles, meaning that by corresponding parts of congruent triangles are congruent, WTU is going to be congruent to WZU. So it's going to be congruent to angle WZU. TW, arc TW, that's this arc right here, is congruent to which arc? Well, again, we've got congruent triangles, and therefore corresponding arcs must also be congruent. So this arc right here has got to be congruent to this arc as well, which is arc ZW. Finally, we want to know what SX is. SX is right here. This is 10, but since this is the center of our circle, we know that this is going to be the radius, which we were given here. So this has got to be 8, and 10 minus 8 is 2, so SX must be 2. 77 says, what part of the circumference of a circle is represented by arc whose measure is pi radians? So we know that pi radians is equivalent to 180 degrees, which is half a circle. Therefore, the part of the circumference that's represented by pi radians is half of the circumference. For 78, what part of the circumference of a circle is represented by an arc whose measure is pi over 3 radians? So pi over 3 radians is equal to 1/3 of pi radians, which we know is half the circle. So 1 full circle equals 2 pi. And if we break that into sectors of 3, so think about this. Let me draw a picture. If we have a circle, 1, 2, 3 gives us, we have 1, 2, 3. Pi over 3 radians is 1/3 of pi radians, so 1/3 of the semicircle. Then we're going to just do that again, and we're going to have another 1, 2, 3. So what this tells us is we're going to have 6 sectors total, and we're going to have, 1 full circle is going to be 6 pi over 3. And therefore, we're going to be taking 1/6, so that's this section right here, 1/6 of the circumference. So just to review that again, pi over 3 radians is when we divide a semicircle into 3 sectors, meaning a full circle is going to be divided into, we're going to have 6 sectors total. So if I want just this part right here, that's going to be 1 out of 1, 2, 3, 4, 5, 6. 1 out of 6 parts of the entire circumference. Gerald is creating a new target game. The game involves concentric circles. That means circles with the same center, P, so our center is right here, and sectors as shown below. The radius of the smaller circle is 6 inches. So we know this is going to be 6 inches, this is 6 inches, this is 6 inches, this is 6 inches. While the radius of the larger circle is 9 inches. So this is going to be 9 inches, this is 9 inches, and so on and so forth. And just looking at this right now, 6 inches plus what gives us 9 inches? So this little segment right here is going to be 3 inches, as is this, as is this. The length of arc DE, so I'm actually going to erase some of this so we can see this. Arc DE, the length of it is 12 inches, and the measure of angle APC, so this angle right here, is 40 degrees, and the measure of angle JPH is 90 degrees. So we've got a right triangle right there. What is the length of arc AB? There's 2 ways to solve for this. One of the ways we know is all circles are similar, so corresponding parts are going to be proportional. So I know that arc DE, the length of that is 12 inches, and that's formed when it has a radius of 6 inches. So I could look at it at 12 inches, an arc length gives me a radius of 6 inches. So what arc length am I going to have when my radius is 9 inches? Well, cross multiplying, 12 times 9 is 108 inches squared equals 6x inches. I'm going to divide by 6 inches. And 108 inches squared divided by 6 inches is going to give me 18 inches. So I know that the arc length is going to be 18 inches. Another way I can do this, which is actually going to help me solve question number 80, is that I know that this arc length is 12 inches and the radius is 6 inches. So S equals R theta is how we find arc length, S being our arc length, R being our radius, and theta being our arc measure in degrees. So we know we have 12 inches. We know our radius is 6 inches. We just need to find theta. So divide by 6 inches. Theta is going to equal 2, and we know that theta is in radians. So 2 radians. So that means that DPE right here is going to be, I'll just put this over here, 2 radians. So I can find my arc length by taking my radius, my new radius. So I'm now doing AB. My new radius is 9 inches times my theta of 2 radians, because they're still going to have the same central angle and therefore the same angle measure. 9 times 2 is 18 inches, which is what we got in 79. Now in question 80, it says, what is the radian measure of angle APB? Well, if this angle is 2 radians for this circle, it's going to be 2 radians for this circle. So we know that the answer is going to be 2 radians. Next, we're asked, what is the area of sector EPD? So what's the area of this sector right here? Well, we find area by taking the formula x over 2 pi times pi r squared. Now, I'm using x over 2 pi because I know my angle measure in radians. So I'm going to have 2 over 2 pi times pi, and my radius is 6 inches squared. Well, the 2's are going to cancel out, the pi's are going to cancel out, and I'm going to be left with 1 times 6 inches squared, which is 36 inches squared. And that is the area of sector EPD. Next, I'm asked, what is the length of arc AC? Well, we're given 40 degrees, and for this we know the radius is 9 inches. So my arc length is going to be of the formula S equals x over 360, since now I'm given degrees, times my circumference of 2 pi r. It's part over the whole of the circumference. So I'm going to have 40 over 360 times 2 pi times my radius of 9 inches. Well, 40 over 360 is 1/9, and 2 times 9 inches is going to be 18 pi inches. And then 18 divided by 9 is 2, so I'm going to get 2 pi inches. And I'm going to leave my length in 2 pi inch form rather than multiplying out by 2 pi. 83 asks for what is the area of sector EPH. So EPH is this sector right here. We know the degrees, we know the radius, that's all we need. My area is going to be x over 360 times pi r squared. So my area is going to be 40 over 360 times pi r, which is 6 inches, and I'm going to square that. So again, 40 over 360 is 1/9 times pi times 36 inches squared. Well, 36 divided by 9 is 4. So my area is going to be 4 pi inches squared. Because this is area, if you wanted to, you could multiply out the 4 pi. You'd get approximately 12.566 inches squared. But you can leave your answer in terms of pi. Finally, for question 84, what is the measure of the circle segment bounded by JH? So JH is right here, and arc JH. So basically, I want to know what is the area of this sector. So looking at this, what we can find is the area of this sector, which is sector HPJ. Find the area of this triangle and subtract the whole minus the part to get the remaining part. So I need to find, I'm going to move this down a bit. I need to find the area of the segment by taking the area of the sector minus the area of the triangle. So the area of that sector, well, we know the degrees. We know 90 degrees. So I'm going to do x over 360 times pi r squared. And that's going to be 90 over 360 times my radius of 6 inches squared. Now I'm going to do the triangle, which I just need to do 1/2 base times height. Because this is a right triangle, I know my base is 6, my height is 6. So it's going to be 1/2 base times height. So minus 1/2, 6 inches times 6 inches. So 90 over 360 is 1/4 pi times 36 inches squared. And I'm going to subtract it by 1/2 of 36 inches squared because 6 times 6 is 36. So 1/4 pi times 36 inches squared is going to be 9 pi inches squared. And then half of 36 is going to be 18 inches squared. So I'm going to rewrite this as 9 pi minus 18 inches squared. And that's going to be my answer, 9 pi minus 18 inches squared. Or I can multiply it out and get 10.274 inches squared. Just don't forget your units, but it doesn't matter which one you use in the end. Question 85. A piece of jewelry is a segment of a circle with radius 10 millimeters as shown in the shaded region below. What is the area in square millimeters of the shaded region? Your answer may be in terms of pi or rounded to 2 decimal places. If you use pi in a calculation, use the calculator's pi key. So what we're going to be finding is the area of this shaded region. What we can do is we can find the area of a sector and we can find the area of this triangle and then subtract the area of the triangle from the area of the sector to get the area of the segment. So what I'm saying is the area of the segment equals the area of the sector minus the area of the triangle. So, area of the sector, we're given 90 degrees. We can also look at that as pi over 2 if you want, but I'm just going to use 90 degrees because I know that. So x over 360 is my degree calculation times pi r squared, and my area of my triangle is going to be 1/2 base times height. So we know we're going to have 90 over 360 times pi, and my radius is going to be 10 millimeters squared. My triangle, it's a right triangle, so I can do 1/2 base, which is 10 millimeters, times height, which is 10 millimeters. 90 over 360 simplifies to 1/4 times pi times 10 millimeters squared, which is 100 millimeters squared, minus 1/2 of 10 millimeters times 10 millimeters, which is 100 millimeters squared. So 1/4 times pi times 100, well, 100 divided by 4 is 25. So we're going to have 25 pi millimeters squared minus 1/2 of 100, which is 50 millimeters squared. So I'm just going to put these together, and we're going to have 25 pi minus 50 millimeters squared, which will be one of your answers if you leave it in terms of pi. Otherwise, you can round it to 2 decimal places, which comes out to 28.54 millimeters squared. And that is the end of the Unit 5 section of the Honors Geometry Exam Review.